This is the revision assignment 3. It's a CHIJ Katong Convent mid-year 2017. This is a Sec 4 Pure Chem. Okay, first question. So you have A, B, C, D. Which substance has particles in a disorderly and closely packed arrangement at room temperature and pressure, which is at room temperature, which is 30 degrees Celsius. So let's go through the substances one by one. 30 degrees Celsius would be above its boiling point. So A would be a gas, okay? And then if you look at B, 30 degrees Celsius is in between the boiling and melting point, meaning that it would be a liquid. And then C, 30 degrees Celsius is below its melting point, so it is a solid. And D would be a solid as well. So closely packed arrangement, disorderly. So it must be the best description would be for liquid. B. Okay, because for gas you cannot call it closely packed, and then for solid you cannot call it disorderly. So you have disorderly, closely packed. The best description would be for liquid. Okay, for question 2, the diagram shows a setup to investigate diffusion of gases. So diffusion of gases, in this case you'll have to look at the MR. Okay, because rate of diffusion depends on the MR, depends on the temperature. So in this case you have to look at the MR. So first thing is hydrogen chloride. Hydrogen chloride is HCl. Okay, when it dissolves in water, it becomes hydrochloric acid. So hydrogen chloride, what would be the MR? So the MR is 1 plus 35.5, which is 36.5. Okay, and then it says that which unknown gas would cause the water level at X to rise and then return to X after a few hours. Now, at this point, the water level here and here, they are the same, which means that the pressure and the pressure here and the pressure here will be the same. Now, so the reason that X rises is because the pressure here decreases. And when the pressure here decreases, it's because the rate of diffusion of the gas here out of the porous pot is faster than the rate of diffusion of the gas inside here into the porous pot. Okay, out more than in. That's why the pressure in this porous pot decreases, and that is why this water level at X rises. Okay, so which means that the rate of diffusion, okay, rate of diffusion out of porous pot must be faster than the rate of diffusion into porous pot. Out faster than in, meaning that the gas inside here has a smaller MR, than the unknown gas outside. Okay, so that it can move through the porous pot faster. Smaller MR meaning that it can move through, it can diffuses out of the porous pot at a faster rate. So basically what this thing means is the MR of gas in porous pot must be smaller than the MR of gas outside porous pot. And the MR of gas outside porous pot is basically the unknown gas. This is the unknown gas. So the unknown gas must have a larger MR than the gas inside the porous pot, which is HCl. So HCl is 36.5, which means that the unknown gas would have an MR bigger than 36.5. So we have to calculate argon. What is argon? AR, right? Argon is AR, and the AR, the MR, now the MR and the AR will be the same, which is basically the chemical formula for argon is AR. It is monatomic, so the MR is 40. All right. And then how about hydrogen? Hydrogen is H2, so the MR is 2. How about nitrogen? Nitrogen is N2, so the MR would be 14 times 2, which is 28. And then oxygen is O2, the MR would be 16 times 2, which is 32. So which one is bigger than 36.5? It is A, argon. Okay, let's look at the next question. Number 3, the diagram shows a setup used to obtain carbon monoxide gas. So what is the purpose of solution R? Solution S. So you have calcium carbonate, acid. So acid and carbonate, it would produce carbon dioxide. So it would produce, so carbon dioxide will be produced here. And then you have lumps of charcoal. Charcoal is basically carbon. And then you heat carbon. So inside there'll definitely be oxygen. So carbon, oxygen, you get carbon dioxide. Now the oxygen inside will run out slowly. When the oxygen inside here run out slowly, the charcoal will still be burning. So the charcoal will react with the carbon dioxide to form carbon monoxide. So eventually there'll be a lot of carbon monoxide being produced here. Okay, and then there is carbon dioxide here. Some carbon dioxide will be able to sneak through the charcoal without reacting with it. So there'll be carbon monoxide going into this solution S, and there'll be carbon dioxide going into the solution S as well. Then after that, the gas that comes out here is only carbon monoxide. See, you have carbon, you have CO and CO2 going into solution S. Then then the gas that comes out here, only carbon monoxide. So this solution S must have reacted with carbon dioxide. Okay, so the purpose of solution S is basically to remove the presence of carbon dioxide gas. So this solution here can be an alkali solution because carbon dioxide is acidic. So it can be an alkali solution, it can be a lime water because lime water does react with carbon dioxide to form calcium carbonate. So this one here could be alkali solution. Okay, it also can be lime water. Okay, number 4, camphor is a substance used in skin ointments, and a natural sample of it is found to contain impurities such as iron 3 oxide, iron and sodium chloride. So you have these 1, 2, 3, 4 substances. The effects of these substances in 3 different types of liquids are shown in the table. So you have water, ethanol and dilute nitric acid. And which substance is the best method to obtain the camphor? Now, the best method to obtain the camphor. Now, let's see the first one. Add dilute nitric acid. Dilute nitric acid, no effect. That means that this camphor doesn't dissolve. Okay, it is a solid, doesn't dissolve. So the other 3 substances all dissolve. Form salt solution means that it will dissolve. Then you filter it. So when you filter the mixture, you will get camphor because camphor is the only one that has no effect. Filter it. Then after that you crystallize it. What's the point of crystallizing it? Because it's not even a solution. Okay, so A is out. You don't need crystallization, you just filter it, that's it. Because camphor, no effect with dilute nitric acid, meaning that it doesn't dissolve. Okay, so if you look at B, you add dilute nitric acid, okay, iron 3 oxide, sodium chloride all dissolve, all react and dissolve. You filter it, you get the camphor, and then you rinse the camphor, you dry the camphor. In that case you get the pure camphor. Alright, so the answer is B. So you only crystallize if you have a solution. Okay, if you have a solution, for example, sodium chloride solution, so you crystallize it, you heat it to saturation, and then you cool it to crystallize to get the salt crystal. Which diagram best represent a mixture of neon and hydrogen bromide? So hydrogen bromide, the formula is HBr. And then you have neon. Neon is a noble gas. So this neon is a noble gas, and noble gas basically is monatomic, 1 atom only. So this is 1 atom. Neon, hydrogen bromide is 2 atoms. So which diagram best represent that? That would be C. Okay, so this one would be hydrogen bromide, HBr, and this would be the neon. Question 6. An atom of element X has 14 neutrons, 13 protons. So 13 protons. From the number of protons, you can write down the electronic configuration, 283. How many electrons does the ion of X have? So now 283, you have X, alright, become an ion. How does it become ion? 283 needs, it's not stable, so need to lose 2 electrons. When it lose 3 electrons, when it loses 3 electrons, it become X3 plus. So this one is 13 electron, this one is 10 electron. Alright, so how many electrons does the ion of X have? 10 electrons. A. Okay, so remember, for atom, number of protons and number of electrons are the same. Okay, number 7, a mass spectrogram provides information on the relative abundance of isotopes. Relative, when you think about isotope, just think about chlorine. Okay, chlorine has 2 isotopes, right? You have Cl35, chlorine 35 and chlorine 37. And what is the abundance? The abundance, that means how abundant it is. That means how many percent of the chlorine is chlorine 35, how many percent is chlorine 37. So chlorine 35 is 75% and chlorine 37 is 25%. This one you have to remember is from the textbook. Copper has 2 naturally occurring isotopes. Okay, it has 2 isotopes, same as chlorine. The relative atomic mass AR of copper is 63.6. So this is a weighted average of the abundances. Which could be the mass spectrogram of copper? Now this one definitely is wrong because only 1 isotope. Okay, then if you look at C, now if you look at B, equal abundance. Now when they are equal abundance, when it is 50-50%, of course the relative atomic mass would be 64. Okay, but the relative atomic mass is not 64, it's 63.6. So this is out. So this is out, this is out. Now let's look at C. Now C, you can see that copper 63 has a higher abundance, about twice than copper 65. Yeah. So this one roughly it is twice. Okay, 1, 2, 3, 1, 2, this is 1, 2, 3, 1, 2, 3, 4. So